Assalamualaikum, guys. So we are from Group 7 and our project is Think Crusher. So this is our group member. First, Muhammad Edham. Second, Haizuddin. Third, Muhammad Alif. Fourth, Muhammad Syazani. And fifth, Muhammad Haikal. In our project, we are using a double acting cylinder and single acting cylinder to demonstrate the crushing operation, including the 5 two-way solenoid impulse valve, 3 two-way solenoid valve normally closed. The crushing mechanism can be observed when the push button is pressed, and the double acting cylinder will hold for 5 seconds for both extended and retract to crush the tin to ensure the tin has reduced its size up to 70% for its original shape. Meanwhile, a counter will be using to measure the number of retraction up to 3 times before it is reset to 0. After that, a single acting cylinder will extend to send the 3 crushed tin to another station. This system will keep on repeating until a reset button is pressed to reset the counter to 0 and stop the whole operation. So this is our list equipment in pneumatic. So we have compressor to supply air to our pneumatic panel, air service unit, manifold. We using 3 two-way directional control valve normally closed. Since we don't have this control valve, we just using 5 two directional control valve with spring return to control the single acting cylinder. We have 5 two-way directional control valves, double solenoid, to control double acting cylinder with proximity sensor. We have push button module, relay module, 3 timer module, counter module, 24 volt power supply, laptop with fluid sim, pneumatic software and banana cable. So this is the electric and pneumatic control circuit that we create from fluid sim software. Will be shown in demonstration video.
Okay, thank you Zani for explaining the electrical and pneumatic control circuit. So right now, I Muhammad Alif and I will be continuing the simulation and analyzing the control circuit of the electropneumatic. Okay, so right now I will go through the our fluid sim. Okay, so from here you can see the circuit and our diagram of the pneumatic circuit, and there's electropneumatic circuit. So when we start, okay, you can see from the supply, we go through the second magnetic sensor, okay, proximity sensor, but it's not activated yet. Okay, so when I press start, the current will go through this relay, KF1 relay, and then KF1 relay will latch. So it will keep going until we push another the second button here, SF2, to reset it. So the same relay will go to the first magnetic proximity sensor to activate timer. This timer is set to 5 seconds. The first timer and the second timer we set to 5 seconds, but the third timer we set to 3 seconds. Okay, we also have counter that set to 3. So when I push this push button, okay, we activate the timer, and then the timer will activate our first solenoid. So we extend to the second one. When it extend the second one, it activates the second timer, to count down for 5 seconds. When the timer goes off, we activate our second solenoid here, MB2, and it also counts down on the our counter here. So when it retracts to the first position S1, the counter will go from 3 to 2. It will count down. Okay. Okay, right now you can see the counter has already go to 2, so it counts as 1. So this one will be repeated until 3 times. After that, after it repeat to 3 times, here you can see this for the counter, it will activate our third solenoid for our single acting cylinder, and will activate the timer. Okay, the timer will set to 3. After 3, the counter will go to 0, and we start again at here. Okay, we will play. So this is the second time. When it retracts, the timer goes to 1. Okay, pay close attention to this. After this, when it retracts, our single acting cylinder will extend. So when they extend, it will count down for the timer for 3 seconds, and after that, we can see this double acting cylinder will extend. So we'll keep repeating this process until I push this button here to reset the timer. So reset the timer and also reset our counter. All the counter and all the timer is reset to its original position. So next, I will show a demonstration of our pneumatic circuit in our in workstation. So this is our demonstration. When the first push button is pushed, the simulation will start. And after 5 seconds, the first piston rod will extend and retract back after 5 seconds. The process will repeat 3 times. When the cylinder retracted, the counter will start to count down. This is alright. This is the second one. Then the second piston rod will extend. The whole process will repeat it continuously until second push button is pushed. The counter will set to 0. Then we will keep repeating it. When the push button for the reset is pushed, the counter is set to 0 and the process has stopped. Right, I will continue about this wiring connection. This is our wiring connection of the pneumatic. This is from the power supply to our ground. Then for the red one is for the supply. Then for the blue banana cable, this is for the grounding. And for the yellow one, is just the tube for hose for the pressure air.
Okay. Firstly, I want to thank our friends for present our project Think Crusher by using a pneumatic. Okay, for this slide, I will present our project by using PLC. As you can see, this is our list of equipment that we use in PLC. Firstly, compressor, air service unit, manifold, 3 two-way directional control valve with normally closed, single acting cylinder, 5 two-way directional control valve with double solenoid. And then we use double acting cylinder with proximity sensor, push button module, PLC, CP1E training kit, laptop with CX programmer software, USB cable, and lastly banana cable. Okay, for this slide I will present our ladder diagram that we build by using CX programmer software. As you can see at the run 0, we have push button start, push button reset, and relay the output, and the relay will latching between start push button. As you can see, when we start the push button, the relay will energize. The function of push button reset is to reset all the operation. Okay, for the run number 1, we have load for relay, load for sensor number 1, and we have a timer number 1. We put it T000 and the set value #50. The relay will energize the limit switch 1 and the timer will start counting. And the run number 2, we have load for timer number 1 and go to the MB1. After a timer counting 50, it will energize the MB1, which is in the demo, the cylinder will be expand. Okay, run number 3, we have load for sensor 2 and go to the timer number 2, which is T001. We put the value #50. The limit switch 2 will be energized timer 2. For the run number 4, we have load for timer number 2 and go to the timer MB2 and connected with counter C001. We set the value 3 times and go to the load timer number 3 and latching with the push button reset. After timer number 2 is counting, it will energize the MB2 and the MB2 will be retract. Okay, for the run number 5, we have load for C1, go to the timer number 3, which is T003. We set the value #30. The counter will be, after counter start counting 3 times, it will energize the timer number 3. And lastly, run number 6, we have load for C1, go to the MB3. After, as you can see, after 3 times of timer, it will be energize the MB3, so MB3 will be expand. Okay, my friends will present simulation load using work online simulator by using CX programmer.
For simulator ladder diagram using work online simulator, first need to compile to check any error in coding. Second, start work online. When push button start is pressed, the current 24 volt VDC will flow through and energize the relay. After relay is energized, the contact relay is used as a latching for continuous active even when push button start is released. When relay is active, sensor 1 is active, we'll start the timer 1 for 5 seconds. After 5 seconds, T1 will energize the MB1. When the MB1 is energized, the air will flow and extend the double acting cylinder. When S2 is active, we start the timer 2 for 5 seconds, and after 5 seconds, we'll energize the MB2. When MB2 is energized, the air will flow and retract the double acting cylinder. When T2 is active, the current will flow into the counter C1. The process will repeat it for 3 times. Sensor 1 is active. Start the timer 1 for 5 seconds. After 5 seconds, MB1 is energized. Sensor 2 is active. Timer 2 is active for 5 seconds. We'll energize the MB2 for the 2 times. Process repeat again. Timer 1 is energized. MB2 is energized. Sensor 2 is active. When counter is 0, we'll energize the timer 3 and then we start we energize the MB3. Process is repeated again. When timer 3 is active, we'll reset the counter, so the process will continues active. So again for the last one. The contact will start the timer for 30 seconds to reset, and when C1 is active, we'll energize the MB3. So right now its counter is show 2. When push button reset is pressed, when push button reset is pressed, we stop the whole operation, and the value for the counter will be reset also. Okay, for the next video, we will show the demo for the PLC simulation.
Okay, this is our project complete with the PLC and pneumatic, right? So when I push this push button, it will energize, and then the slot nut will extend and hold for 5 seconds. Then we go to track and repeat 3 times. After 3 times, we show in this PLC ladder diagram, and then this single cylinder will push the can to the other conveyor belt. Okay. So I will demonstrate it, right? This is the first time we show the counter here. When it extends, we hold for 5 seconds. Okay, this is the last one. After the third one, the single acting will extend. Okay, and then it will repeat it until we push this reset button here. Okay. So the timer and the counter will be set to 0. Okay, that's all.
Okay, for this slide, I will show our connection PLC hardware. As you can see, a service unit go to manifold, manifold go to valve, valve go to the cylinder. Positive valve go to the power supply, negative valve go to the output PLC. Sensor and push button go to the input PLC. Push button and PLC supply by 24 volts. The picture below, as you can see, we draw a schematic diagram for our PLC connection. Thank you for listening our report presentation. Assalamualaikum.